The grand illusion. Is our reality just a shadow? Our world feels solid and real, defined by three familiar dimensions: length, width, and height. We move through these dimensions every day, rarely questioning their nature. But what if our reality is just a projection, a shadow cast from a higher, unseen dimension? Imagine a two-dimensional flatlander, unable to comprehend the third dimension. If a 3D object passed through their world, it would seem magical and inexplicable. Could we be just as blind to higher dimensions, mistaking shadows for reality? Plato's allegory of the cave imagined prisoners mistaking shadows for the real world, unaware of a richer reality beyond their perception. Modern physics echoes this metaphor. Are the forces and particles we observe just shadows of a deeper, multidimensional reality? This idea challenges the limits of our perception and suggests our universe might be a mere slice of a grander structure. The laws of physics, as we know them, could be local rules, not the ultimate truth. If our three-dimensional existence is not the final word, what lies beyond? The deepest truths of the universe may be hidden, just beyond the veil of our senses. To explore this, we must re-examine the very fabric of space and time. Our journey begins by questioning the reality we take for granted. Einstein's revolution time as the fourth dimension. For centuries, space and time were seen as separate, absolute entities. But in the early 20th century, Einstein shattered this view with his theory of special relativity. He showed that space and time are intertwined, forming a four-dimensional fabric called spacetime. Time is not a universal constant. It bends and stretches depending on your motion. Gravity, Einstein revealed, is not a force but the curvature of spacetime itself. Massive objects like stars and planets warp this fabric, guiding the paths of everything around them. The Earth orbits the Sun not because of an invisible pull, but because it follows a curved path in spacetime. This radical idea redefined our understanding of the cosmos and established time as a real, physical dimension. We can't move freely through time as we do through space, but its inclusion as a dimension opens the door to even deeper questions. If time is the fourth dimension, could there be more, hidden from our senses? Einstein's insights invite us to imagine a universe far stranger than we ever thought possible. The next step is to ask, what else might be lurking in the higher dimensions? The mystery of weak gravity, a leak in spacetime. Of the four fundamental forces, gravity is bizarrely weak. A fridge magnet can overpower the entire Earth's pull. This weakness hints that our four-dimensional model of spacetime might be incomplete. One radical idea: gravity leaks into extra, unseen dimensions, while the other forces are confined to our universe. Imagine our universe as a sheet in a larger space, the bulk. Gravity, as a property of spacetime, spreads into all dimensions, diluting its strength. The gravity we feel is just a faint echo of its true power, most of it lost to higher dimensions. This could explain why gravity is so much weaker than the other forces. It reframes the question. Maybe the other forces aren't unusually strong, they're just trapped in our dimension. Gravity's weakness may be a clue that our universe is part of a much larger, multi-dimensional reality. The search for these hidden dimensions could unlock the next great revolution in physics. Whispers from the dark matter and dark energy. Everything we see, stars, galaxies, ourselves, makes up less than 5% of the universe. The rest is dark matter and dark energy, invisible yet shaping the cosmos. Dark matter holds galaxies together, its gravity felt, but its nature unknown. Dark energy drives the universe's accelerating expansion, acting like a mysterious anti-gravity. Some theories suggest dark matter and dark energy are evidence of higher dimensions, perhaps particles or forces leaking from parallel worlds. We feel their effects, but can't see or touch them. These cosmic mysteries hint that our universe is influenced by a hidden, higher dimensional architecture. The missing 95% may be a sign that reality is far deeper than we imagine. In the quest to unify physics, string theory proposes that the universe is made of tiny, vibrating strings, not point-like particles. Each vibration creates a different particle, like musical notes from a violin string. For the math to work, string theory requires 10 or 11 dimensions, far more than the 4 we experience. The extra dimensions are thought to be compactified, curled up so small we can't detect them. Imagine a garden hose from far away. It looks one-dimensional, but up close, it has a hidden, circular dimension. The universe may be similar, with hidden dimensions at every point in space. Without these extra dimensions, string theory collapses. These hidden realms could hold the key to unifying all forces and particles. Our reality may be just a small part of a much richer, multi-dimensional symphony. Braneworld theory builds on string theory, proposing our universe as a 4-dimensional brane floating in a higher dimensional bulk. Everything we know is confined to this brane, like characters trapped on a movie screen. Most particles and forces are stuck to our brain, but gravity can leak into the bulk, explaining its weakness. This model suggests parallel universes, other branes, could exist just out of reach, each with its own laws and matter. We can't see or touch these parallel worlds, but gravity might let us sense their presence. The mysterious pull of dark matter could be gravity from matter on a nearby brane. Our universe may be just one of many, separated by a microscopic distance in a higher dimension. This idea transforms our understanding of reality, hinting at a vast, unseen multiverse. The boundaries of our universe may be far more porous than we ever imagined. The search for evidence of other branes is one of the most exciting frontiers in physics. Could we one day detect a neighboring universe? Higher dimensions aren't just theoretical, they may help explain quantum weirdness and everyday mysteries. The double-slit experiment shows particles behaving like waves, as if existing in multiple places at once. Observing them collapses this wave, forcing a single outcome, suggesting reality is not solid until measured. Some physicists speculate this wave-like behavior could be a glimpse of higher dimensions, with particles existing across them until observed. It's as if we see only a slice of their true, multidimensional nature. Even in daily life, oddities like déjà vu or vanishing objects tempt us to imagine hidden dimensions at play. While likely tricks of memory, these moments remind us how little we truly grasp about reality. The quantum world hints that the universe is far stranger than our senses reveal. Perhaps the boundaries between dimensions are thinner than we think. The mysteries of quantum mechanics may be windows into a deeper, multi-dimensional cosmos. If extra dimensions exist, the implications are staggering. Our universe could be just one page in an infinite cosmic library, part of a much larger structure. What might exist in the bulk? Other forms of matter, energy, even life, governed by laws we can't imagine. Beings in higher dimensions would see our world in ways we can't comprehend, appearing and disappearing at will. Our reality might be more fragile than we believe. Some theories suggest the Big Bang was a collision between branes. Future collisions could reset our universe or change its laws entirely. Gravitational influences from the bulk might explain dark matter and dark energy. Unlocking the secrets of higher dimensions requires not just new technology, but new ways of thinking. We must be willing to abandon comfortable notions of space and time and embrace a universe far stranger than we dream. By daring to look beyond our senses, we may discover that the answers to existence have been hidden in plain sight, in dimensions just waiting to be explored.